Welcome. This is my FTT-106 Module 4 submission, merging 2 field strip and blueprint studies into one presentation. The Taurus TCP 738 Micro Compact 380 and the AR-15 rifle. The deck moves throughout the 4 phases: safety, controlled disassembly, blueprint interpretation, and personnel reflection. Throughout, the emphasis is on professional tool discipline, finesse over force, and connecting real engineering talents as to how each firearm actually functions. All right, Mark here. Okay, Mark here. Today's June the 21st, 2026. This is Sonora Desert. This is FTT 106, week 4, assignment 4. And I'll be showing you how to tear down to a field strip of my Taurus 380 and my AR-15. There is no ammunition in the workplace. Weapon is fully clear. Slide is locked back. It's pointed in a safe direction. Clear. Magazine well clear. No ammunition. Is safe and clear. My AR-15 slide is locked back to the rear. No ammunition in the workspace. Barrel is clear and magazine well is clear. Everything is safe and ready to be worked on. Safety first. Every job starts here. Nothing on the bench happens until the firearm is proven safe. This phase merges the safety doctrine common to both the Taurus TCP 738 and the AR-15. Clear the weapon, control the muzzle, banish live ammunition from the workspace, and wear eye protection. Skipping safety is the single fastest way to cause an injury or damage a customer's firearm. Clearing is non-negotiable and is done the same disciplined way on every platform. On the Taurus, the magazine leaves the bench. The chamber is locked open, and I will verify it empty by sight and by touch. Eyes can be fooled, a finger cannot. On the AR-15, the magazine is ejected and the bolt locked to the rear before the same visual physical chamber check shown here. Why it matters? The overwhelming majority of negligent discharges happen on guns the handler knew were unloaded. Physically separating ammunition from the workspace removes the possibility entirely. This is a section on tearing down the weapon, TCP 738. Again, just to make sure it's very well understood, there is no ammunition in the workspace. Weapon is clear. Slide is locked back. I'll be taking apart my 380. Weapon is secure. There is no ammunition in the workspace. Barrel is locked back. I'm going to go ahead and bring the barrel back, the slide back forward, bolts back forward. These 3 habits are the backbone of bench safety. Muzzle discipline is a continuous behavior and not one-time check. A cleared gun is still treated as if it can fire. The zero ammo rule eliminates the one ingredient requiring for a discharge. Eye protection matters specifically because of stored spring energy. The Taurus uses a high-tension dual recoil spring, and the AR-15 has spring-loaded detents and a buffer spring, any one of which can launch a small part toward your face if control slips. Part 1 is the hands-on one. Good disassembly is about 3 things: choosing the right tool, following the right sequence, and applying finesse instead of force. I cover the Taurus TCP 738 first, then the AR-15, so you can compare how the same professional principles adapt to a polymer micro-compact pistol versus an aluminum receiver rifle. Tool fit is the first line of defense against cosmetic damage. A flat head that exactly fills the takedown pin slot, spreads load evenly, and resists camming out. An undersized or worn bit concentrates force on one edge, slips, and gouges the polymer frame. Exactly the kind of damage a customer notices immediately. Gripping near the tip trades a little leverage for a lot of control. Why it matters? On a basic field strip, the most common avoidable mistake is a slipped screwdriver, and it is almost always a fit problem, not a strength problem. This is a section on tearing down the weapon, TCP 738. Again, just to make sure it's very well understood, there is no ammunition in the workspace. Weapon is clear, slide is locked back. I'll be taking apart my 380 real fast. You can really pull the takedown pin with no other tools other than your fingernail. Just slide it back, pop the pin, and it'll come straight apart, and that's what I'll be doing. But these are the tools I might use. I may use some kind of a pry underneath the pin to pop it up, but my fingernail works just good, just as well. You may put a piece of masking tape under there so not to mark. That's what you would do there. I have a brass mallet in case I have any problem popping it out or putting it back in, which I won't. Okay, so the takedown process down to the field strip. I put my finger underneath the pin, and I'll slide back while pulling on the pin with my fingertips. My nails. Pull the pin out. The pin is out. I have a magnetized tool bin, so I don't tool portion pad, so I won't lose my pin, and slide the slide right off. One thing to be careful of: this spring is a dual spring setup with the pin. Be very careful. Put backward pressure and hold both springs and pull out. Then both springs will come apart. The barrel. Slide the barrel out. Rock it up, rock it out. And that is the field strip portion of the Taurus 380. No specialty tools required to take it apart. Putting it back together, barrel back in. Make sure the lug's locked all the way back so the pin and the springs will fit. Again, a dual spring setup. One spring in the other. Pin in. Slide it into the hole on the guide. Push forward. Being careful not to shoot the spring, the pin across the room. Once it's down in the notch, it is fully seated. You'll position my pin, pushing against the retaining spring. Just so far as it doesn't stick through the hole. Then I'll slide my section back on the upper up on top. Pull back till the notch lines up while pushing back with my thumb. Pin is in. Locks back. Locked back. Function properly. Slide forward. Pull the trigger. Pull back. Release. 2 clicks. Reset, pull again, do it again, 2 clicks, resets, and that is the full tear down of the 738 380 TCP Taurus. When a part binds, the instinct to hit it harder is exactly wrong. A nylon or brass hammer delivers persuasion that is softer than the steel and polymer it contacts. So it moves the part without marring the finish. Likewise, standard hardware store pliers have serrated jaws that bite into and ruin any surface and they grip. Parallel jaw gunsmithing pliers apply even pressure without scarring the pin. The reoccurring theme. The tool absorbs abuse, never the firearm. Sequence is everything on the 738. That a small 1/8 of an inch slide or retraction is what unloads the barrel lug from the takedown pin with the tension relieved. The pin slides out with almost no force. If you skip that step and try to muscle the pin while the slide is in the battery or locked fully back, the pin is pinched against the lug. And the next thing that gives is either the pin shearing or the polymer frame housing cracking. Why it matters? A cracked frame can total an inexpensive pistol, turning a 5-minute field strip into a replacement. Finesse is controlled. Deliberate movement, letting the slide slam forward on the empty chamber, hammers the lugs in pure unavoidable wear. Lifting the barrel straight up and lifting it out keeps it from dragging across the ejection port, which scratches easily, and keeping fingers off the internal ejector while handling the frame protects a small, easily bent part. None of these requires strength, it requires patience. The dual recoil spring. This is the single highest energy moment of the Taurus field strip, and the reason eye protection is mandatory. The nested dual recoil spring stores a lot of energy. It is short package because they have to cycle relatively heavy slide over a very short travel. The controlled move is to push the guide rod slightly forward and clear its seat. Lift it and then ease it back rather than letting it spring free. Loose thumb control and the assembly becomes a projectile. Best case, you spend 20 minutes hunting for a tiny part. Worst case, it hits an unprotected eye. Finish preservation is the visible signature of professional work. The 100% standard is literal. The gun should leave looking exactly as it arrived, or better. The methods are simple and cheap. Painter's tape around the takedown pin area gives a slip tool a sacrificial surface instead of the frame. A bench block supports the frame so you are not fighting it. A constant awareness keeps steel tools away from the slide. Why it matters. Customers judge competence by cosmetics. A perfectly functioning gun returned with a fresh scratch still reads careless work. Parts organization is reassembly insurance. Laying parts out left to right in removal order turns reassembly into simply running the sequence backwards. There is no guessing and no orphan parts. The magnetic tray matters most for the tiny components that a sleeve or a bump can sweep off the bench and into the void of the shop floor. Why it matters? A single lost D10 or spring can stall a job for days, waiting on a replacement. The AR-15, punches and mallets. The AR-15 is pin driven. So punch selection is the equivalent of the Taurus' screwdriver fit. A correctly sized punch contacts the full face of the pin. An undersized one slips and mushrooms the pin end, which then refuses to pass through its hole and on reassembly. A brass mallet is softer than the aluminum receiver and steel pins, so it moves parts without marring. Same doctrine as the pistol. Match the tool to the part and tap, never hammer. But I got my pin removal tool, my brass mallet. I will pop the pin slowly out. Slowly out, pin is out. It'll rock forward, which it did. I have a dummy magazine in there that's going to hold my weapon in place. I don't know where my block is that I would use to mount this to the device. All right, come on back. Barrel handle, slide handle out. Barrel bolt carrier group is out. Pull my firing pin retaining pin. I have a scribe to do that. I flip underneath the cotter pin, pull the pin. Firing pin's out. Remove my retaining lug. Rotate it 90 degrees. It is out. Bolts out. Carrier. Bolts the firing pin in. Whoops. Now I'll put my retaining lug back in on removing and reinstalling the firing pin. Alright. Bolt back in. Lined up my lug. Drop my lug in. When you put the lug back in, make sure you got the larger hole at the top, not at the bottom. It'll go a lot harder to put in, like I was trying to do with it at the bottom. Alright, retaining lugs back, the lug's back in. It's rocked all the way back. Hole lines up. I'll put my firing pin back in. Firing pin's back in. Firing pin's back in. Cotter pin's in. Retaining fire pin returning pin. It's in. Slide back in. Bolt carrier group back in. Bolts back in, carrier groups back in. Slide the upper down onto the lower, pop the pin in, fingertip. It is in. Alright, quick function check. Slide back, slid back to the rear position. No ammunition in the magazine. Bolt locks to the rear. Slide it back forward. Pull trigger. Remove from safe, which it is. Pull trigger, slide back, relax forward, let go of the trigger. Should hear 2 clicks. And you did, 2 clicks. Everything reset, back to safe. Pull trigger, nothing happens. Again, nothing happens. And then resets. Back to safe, reset back to safe. Bolts lock back to the rear, showing that a weapon is fully clear. Some AR-15 tasks demand a purpose-built tool, and the castle nut is the clearest example. The armorer's wrench seats squarely in the castle nut notches and lets you apply even torque without slipping. Reach for the pliers or a pipe wrench instead and you'll cam off, round the notches, and gouge the buffer tube finish. Damage that compromises both appearance and the structural integrity of the receiver extension assembly. The right specialized tool is cheaper than the repair. Like the Taurus, the AR-15 has a sequence that exists for safety, not ceremony. Separating the receivers first puts the gun in a stable, predictable state before you even touch the spring-loaded buffer. Reverse that order, release the buffer detent while the receivers are still adjoined, and the buffer can rocket forward into the upper receiver under spring pressure, damaging parts and surprising the handler. Respecting the order keeps stored energy contained until you're ready for it. AR-15 Finesse centers on the tiny spring-loaded detents, starting a tight takedown pin with a non-marring tool protects the anodized lower. The most important habit is cupping your hand over the pivot pin detent as it comes out free. That detent and its spring are notorious for launching across the shop. And a cupped hand turns a lost part hunt into a non-event. Urethane bench locks help the receiver steady so you're working with a control instead of chasing a part around the bench. The zero marring standard carries over strict directly from the pistol work. On the AR-15, the vulnerable surface is the anodized aluminum, which scratches and shines if a steel punch slips. Painter's tape around the high-risk areas, like the bolt catch pin, gives any slip a sacrificial layer to land on. The principle is identical across both firearms. Protect the finish proactively because a scratch added during service is the most visible and least favorable kind of mistake. If anything, organization matters even more on the AR-15 than the pistol because of the sheer number of tiny detents, springs, and roll pins. Each one goes straight into a magnetic tray the moment it comes out. Grouped logically to a reassembly is orderly rather than a scavenger hunt. Why it matters? These micro parts are the easiest things in the shop to lose and among the most annoying to source individually. So a dropped detent can stall an otherwise finished job. Part 2 shifts from the bench to the blueprint. Reading a dimension and its tolerance is what separates a parts changer from a gunsmith who can diagnose why a gun is failing. I walk through the 3 critical measurements on each platform, and for every one, connect the number on the page to the real mechanical sequence. The AR-15. This bridges into the AR-15 tolerances. The platform's legendary reliability and parts interchangeability come directly from its Mil-Spec dimensional discipline. Being able to read those blueprints means a gunsmith can verify a lower receiver's in spec on the bench, catching an out-of-tolerance part because it can cause a malfunction or a safety problem at the range. The AR-15's takedown and pivot pins holes are held to a 1/4 inch plus 1/1000th. These 2 pins join the upper and lower receivers so that their fit directly controls how tightly the gun locks together. An oversized hole introduces play between the receivers, the dreaded rattle that loosens lockup and degrades accuracy. An undersized hole is even more immediate. The pins simply won't pass, and the rifle can't be assembled at all. Measurement 2 is the most safety critical on the rifle. The hammer and trigger pin holes at 0.156 inches plus 1/1000th minus 0. The unilateral tolerance again guarantees the pins will always fit while capping how loose the holes can be. The stakes here are higher than the rattle. The fire control geometry depends on these pins sitting at precise locations. If the holes wear or the egg out into ovals, the hammer and trigger engage at the wrong angles, which can cause the failure to reset or, worst case, an uncommanded discharge. This is exactly the kind of wear a gunsmith must recognize and condemn. The buffer tube thread callout locks thread callout looks cryptic, but every field tells a story. 1 3/16 is the diameter. 16th is threads per inch. UN is the United National Thread Form. 38 means a class 3, that is tight internal thread. Reading that string fluently lets a gunsmith confirm a buffer tube and a receiver are correctly matched. Why the tight class? The receiver extension absorbs the full recoil impulse of the buffer and spring on every shot, so a loose or mismatched thread could strip under that repeated pounding. Part 3 is my reflection, pulling together what both projects taught to me. The themes were consistent across the Taurus and AR-15 tool techniques. Finesse under pressure, blueprint confidence, and how all of it applies to real gunsmithing work. The first 2 takeaways are about the hands. Tool technique reframed how I think about basic work. The right bit or punch is not a convenience. It's the thing standing between me and a scratched, cracked, or stripped firearm. Finesse was the harder lesson. The dual recoil spring on the Taurus and the detents on the AR-15 both punished any attempt to rush. Why this transfers to the real gunsmithing customers are trusting you with a valuable property. And the difference between a pro and an amateur shows up first in tool discipline and patience. The last two takeaways are about the mind. Reading real tolerances reward my sense of precision. A few thousandths of an inch decides whether a gun runs or fails. So close enough has no place in diagnosis. And trying that back to the hands-on work is where it all comes together. I can now look at a worn hole or an out-of-spec surface and predict the malfunction it will cause. That diagnostic ability, not just swapping parts, is exactly what defines a professional. It is what I'll carry into the trade. That closes the presentation. To recap, we cleared and proved both firearms safe, performed controlled disassembly of the Taurus TCP 738 and the AR-15 using proper tools and sequence. Interpreted 3 critical blueprint tolerances on each platform and reflected on how tool techniques, finesse, and blueprint literacy combined into real gunsmithing